Okay, today we are just gonna do some boards go up, please. Separation of variables, differential equations, finding particular solutions. That's when I give you the initial values and you solve for your C. Um, I I want you to write your solutions down because they're gonna ask you to hand them in. I'll let you know. It'll say it in the Google Doc, but just saying it now. So as if we were doing board work in class, and I'm looking around and I'm seeing what you're doing. I just want to see what you're doing. Um, and I will do it in the same way we've done all these, where like I tell you the problem, I tell you to pause it, and then I put the solution up for you. And if you got it right, and you want to move on, you can move on. And if you would like to listen to me talk about what I did, you can do that. And if you got it wrong, then you should definitely listen to it and see where that error was. So first one, dy dx equals 3x squared over 2y. Y of 1 is 4. Now, I will say one thing about these. For all of these, you're solving for a C, but for all of them, I want you to solve for y. I don't want you to solve for y cubed. I don't want you to solve for the ln of y. I don't want you to solve for y squared. I want y equals. So, you can pause and go. Okay, so here is our first solution. You should get y equals square root of x cubed plus 15. Let me go over it. Remember, separation of variables, we get all the y's on one side and the x's on the other. So since the dy is over here, I got to move my 2y, over to that side. I'm going to keep the 2 with the y for now. So multiply that over and multiply by the dx over. That gives me 2y dy equals 3x squared dx. From there, there I integrate. So the integral of 2y is y squared. The integral of 3x squared is x cubed. And then I get my plus c. But I only need to have my plus c on one side. From there, I'm using this. The y value is 4, so that's why this goes to a 4 squared. And the x value is 1, so I put a 1 in here. Well, 1 cubed is just 1. 4 squared is 16. So when I subtract my 1, I get a c value of 15. From there, I'm going to use that over here, and I'm going to combine it with the line before I started solving for my c. So I take this, and that gives me y squared equals x cubed plus 15, my c value. All I did was change the c to 15. From there, I square root. When I square root, I get the x cubed plus 15 in the root, and technically we get a plus or minus out front here, right? Because either a positive or a negative y would 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 fit this equation up here. So I get this plus or minus. In this case, because y is a positive 4, I only take the positive side of the plus or minus. Take note, I can check that. Take the 1, x value, plug it in here. I get 1 cubed, right? And then I get plus 15, that's 16. Square root that, I get my 4. Say this was a negative 4 up here. I'd want to have a negative there so that when I plug in my 1, I get my negative 4 out. Now you may say, well, why do I care? There's not a negative 4 there, but that'll happen later on. So hopefully you're good with this one. Here is our next one down there. Hopefully you can see it. It is y prime, or dy dx, equals 2xy plus y. I'll give you a little hint. Oh, and y of 0 is 5. I'll give you a small hint. You want to factor this y out, right? Write y, open parentheses, leave a space, close, fill in the parentheses, and then do your separation. So do it, press pause, do it. Okay, here's our answer. Y equals 5x squared, 5e to the x squared plus x. So let me walk you through that. I'll show you the whole solution quickly. without saying anything in case you had a small error and you want to fix it. All right, so what I do first, pull my y out, I get 2x plus 1. I can integrate both sides, or sorry, then I separate my variables, divide by y, multiply by dx. That puts the dx here, the y here. Integrate this side, I get ln absolute value of y equals x squared plus x plus c. That's the integral to the right side. From there, remember I said I want to solve for the y part, right? I want y equals at the end. So I know that e to the and ln are inverses, so I'm going to e to the both sides here to get rid of this ln. Okay, so I think I was saying I'd do the e to this side and e to the on this side. Now, that gives me, this cancels and gives me my y, and then e to the x squared plus x plus c. You may say, what happened here? Well, I used some log rules, and actually, I was going to save this for later, but let me explain why I can do that e to the c thing. So 2 to the 5 plus 3. Well, 5 and 3 add to 8, right? So 2 to the 5 plus 3 is 8 2's being multiplied, right? So the question is, if I were to rip this apart into two separate pieces, what would happen? Well, it would be 2 to the 5th times 2 to the 3rd, because this would be 5 2's multiplied by each other. This would be another 3 2's multiplied by each other. So it would be that, right? So the rule here is that 2 to the 5 plus 3 is 2 to the 5 times 2 to the 3. I'll show you how that plays a role up top. All right, so that's what I did here. This plus turned to a times there. Same thing as down below. All right, so what does that do? Well, when x equals 0 and y equals 5, I can plug in 0 for x right here. 0 squared plus 0, that's 0, which gives me e to the 0, which is 1. And that y on the right side is 5, so that e to the constant is 5, right? That's what this line says. That means that this is a 5, right? And then I can just flip the 5 over here because, 2 times 3, 3 times 2, the same thing. I can change the order of multiplication and get that y, this y, is equal to 5, which replaces this, but comes first, times e to the x squared plus x. Hopefully you're remembering this. Okay, so next one here. Dy dx equals 4xy squared, and y of 2 is 1. So the one thing that I'm going to say to you before I ask you to pause it is be careful of your y integration side. There's a common, might be the most common error in calculus on the AP test. You got to use power rule, not ln's. Let's go ahead, pause now, do your work. All right, so this one, there's two answers that I think are good answers that I would take, right? Y is equal to negative 1 over 2x squared minus 9, or y equals 1 over 9 minus 2x squared. So I'll walk you through how we did this. So we do our separation first. Divide by the y squared and multiply by the dx, right? dy over y squared equals 4x dx. This is the negative exponent part. Write that as a y to the negative 2, right? Don't change the way the right-hand side is. Then I can integrate it, right? What's power rule on y to the negative 2? I go up 1 from negative 2. That takes me to negative 1, but then I divide by a negative 1, which gives me this negative. This is an easier power rule. It just gives me 2x squared plus a constant. From there, I get negative 1 over y. I'm rewriting that negative exponent so that I can use it now. Negative 1 over y is 2x squared plus c. So from there, I'm going to use these initial values. Remember, this 2 is an x value. This is a y value. So I'm going to come down here, make x equal to 2, y equal to 1. X, 2, y, 1. So from there, oops, I don't want to show the next problem. From there, this 1 over 1, but negative, was just a negative 1. And this gave me 2 times 4, which was 8, plus a constant. Subtract this over, c is negative 9. Now, the next line is another spot where I think people frequently mess this up. Negative 1 over y, 2x squared minus 9. That's this without this piece right here. A lot of people want to flip this fraction and then flip this and write this as 1 over 2x squared, and then minus 1 over 9, and that's incorrect. Um, I've explained it to you previously. I'm not going to go through that long process now, but what I can do instead is put this guy over 1, and then I can cross multiply, right? So if I cross multiply, multiply by the y, multiply by the 1, I'd have a negative 1 here. I'd have y times this, and then I can divide by this mess, and that's where I would get this from. This would be dividing by the 2x squared minus 9. If you moved your negatives around in a little bit different way, you would get this as well. So either one of these is good. And hopefully you see, 1, the negative power rule, 2, how to deal with the fractions. Okay, one more. This one is mostly straightforward, except for this little negative right here. So dy dx equals fraction bar top e to the x minus 1 bottom 2y. Pause, give it a shot. Okay, here we go. The answer is y equals negative, and that's the only part that I think is tricky, root e to the x minus 8, or sorry, e to the x minus x plus 8. So let's walk through that. I got multiply by the 2y, multiply by the dx, cross multiply there. 2y dy equals e to the x minus 1 dx. Then I integrate both sides. On this side, I get y squared. It's power rule. E to the x integrates to e to the x, minus 1 integrates to minus x, and then we get our constant. From here, I use these values. I get negative 3 squared, right? Squares out to give me a positive 9. E to the 0, that's 1. Most anything to the 0 is 1. Minus x, that becomes 0. So I get 9 equals 1 plus c. Subtract 1, c equals 8. From there, I go back to the line before I started to solve for my c's, which is this one, and I plug in that 8 for the c, which gives me this. From there, I square root. This goes back to the first problem. I get plus or minus this mess, right? Well, what would I need in order to get a negative 3 out of this? I need to take the minus half of it. And why is that? Well, let's test it. If I had the plus half of it, imagine I didn't have this minus here, right? If I take 0 and plug it in for x, I get e to the 0, that's 1. Minus 0, that's 0. Plus 8. This gives me 9, right? If I didn't have this negative here, if I take the square root of 9, well, that's just 3. It's not plus or minus 3, it's just 3. So when I get that 3, it doesn't match this output. So this thing is not the one that gets me to this one. It's the one that gets me to 0, 3. Put the negative on there, and it fits it well. Those of you who have done a conics project, it's kind of like the plus half and the minus half of a conics project piece, right? So we got to take the minus half because this is the minus 3 part of it. If that makes sense, that's great. Hopefully you're getting the hang of this stuff. I'm going to stop the video here and start another one for the next 2 problems.